Hey everyone, welcome back to MLworks. In this video, we'll be discussing how to implement semantic search system using sentence transformer, and we'll use MLflow for logging the model and keeping track of the metrics and parameters that is used for building the semantic search system. Okay, so we'll get started by importing the packages and then we'll slowly move on to MLflow and building the semantic search system. Okay, so the first thing is we import the packages which are MLflow for tracking the experiment and logging the metrics and parameters. And then we have NumPy and Pandas for data manipulation. And then we use sentence transformer for downloading the embedding model. And then we use util for encoding the text into embeddings and vice versa. Okay. And once that is done, we have info signature for while logging the model to MLflow, we want to ensure the MLflow is aware of the inputs and outputs taken by the model. Okay, so that's why we have to pass info signature. So this is already imported, I guess. Yeah, so it is already imported. Next, we want to set up the MLflow experiment and the tracking URI. So since we are running this notebook, we want to track everything that is happening here into MLflow. Okay, so that's why we set the tracking URI as 127.0.0.1:5000, which is the port number. And if you see, I have an MLflow running here. Okay, so if you see here, MLflow server is running here already and it has multiple workers for it. Okay, so we want to just log our model, whatever we run here in our notebook, to be into the MLflow. So that's why we have this tracking URI and we are setting the experiment as semantic search. Now, so semantic search is nothing but, okay, consider you have a bunch of documents, okay, and you have an input query coming in and you want to identify that input query matches any of the given document. So for that, what we do is we convert our existing documents into embeddings, and whatever the input query comes in, that also turned into an embedding. Now this query embedding is matched with the corpus embeddings that we generate from these documents, and whichever is most similar, we pick that out. Okay, that is the whole idea behind semantic search system. So here we have our around 9 to 10 documents we have, and we just which is nothing but a list of documents, and it is presented inside the variable documents. Now let us get started with building the semantic search system and how to log them into MLflow. So the first point is, this is the first point, okay, MLflow.startRun, because whatever we do, okay, the model downloading the model from sentence transformer and then logging that model to MLflow, or performing the semantic search and getting the similarity score between the corpus and the query embedding. Okay, so all this needs to be stored inside MLflow. That's why what we do is we start with MLflow.startRun and perform all these operations like downloading the model, logging the model. All these will be done inside this context manager. Okay, this is the context manager. Now inside this, the name we have given is semantic search system, the run name. Okay, and first what we do is we load the model. Okay, what this will do is it will, from the sentence transformer repo, it will download the specific embedding model. If it is already present, then it won't download. Okay, so we'll have our model here, embedding model. Next is we pass in the params required by the embedding model. Okay, so model name is all mini LM L6V2, and the embedding dimension is we pick it from the model, and what is the maximum sequence length, that also we pick it from the model, and then corpus size is nothing but the number of documents we have it here. So this is our parameters that we want to log in MLflow. So once we have logged the parameters, what we do is we encode our corpus, which is nothing but our documents. So for that, what we have to do is we just have to do model.encode and pass the documents. So this will turn it into kind of floating point numbers for each of the document, a list of floating point numbers for each document. And what we do is by the end, we also want to convert that into a tensor, okay, such that we can manipulate it later if required. So what we do is by the end of this, we'll be having a corpus embeddings for each of the document that is present here. So once the corpus embedding is generated, what we do is we try to log the corpus into MLflow. So here if you see, we create a data frame from pandas. Okay, we pass in the documents. Okay, and then we save it to a CSV file, and that CSV file is logged as an artifact into MLflow. So this is how you want to store your CSV file into MLflow, by using log artifact inside MLflow. Okay, next is, now since we have already generated the corpus embeddings, now we want to test our query will correspond against the corpus embeddings. So what we do is we take around 4 test queries and we try to iterate them and search the top similar document with respect to the query. Okay, so we have 4 test queries, which is what is artificial intelligence, how do neural networks work, tell me about text processing, and what tools help with ML development. So first is we have search results, an empty list. So we iterate through the test queries. Now each searching for this query that will print here, and then we generate the embedding for the query. Okay, and then turn it into a tensor, and we get our query embeddings. Next, what we do is we use something called as util, which is a function from sentence transformer, and perform semantic search, and which will take in our query embedding which we got here on the corpus embeddings, and we get the top k, which is nothing but 3 in this case. For every query embeddings, we'll see top 3 documents, similar documents we'll pick, and this is how we get our similarities, and which is the index 0. This is a kind of what a list will be generated, and we want to pick the first element. Okay, so we get the similarities for each of the query, and what we do is next we create our store results. Store results is nothing but we want to for every query, what was the document that got picked, what was the similarity score against it, what was the rank, because since we are taking 3 elements or top 3 elements, we want to rank them on the top, which is the 1, and which is rank 2, which is rank 3, and each will have its corresponding similarity score. Okay, so the rank 1 will have the highest similarity score, and rank 2 will be having lesser than rank 1, and rank 3 will have lesser than rank 2. So this is how we store our results. Okay, we iterate through the similarity score and get the query, then get the corresponding document by getting the corpus ID, and which will give us the index for the documents, and then we get the score, which is the similarity score, and then the length of the this is just for calculating the rank of the documents that got searched. Next is we are printing this our whatever we've identified as the top 3 results, we are just printing them and corresponding score, similarity score. Next is, since we have created our results here, okay, which is nothing but 4 columns, and which will contain query and document and then similarity score and the rank. What we do is we store this into a CSV file, which is called searchresults.csv, and then we log that into MLflow as well using log artifact. Next, we want to calculate the metric. Okay, in this case, what we do is we calculate the average top 1 score. Okay, what is the similarity score of the first element that is getting fetched? Okay, what is the similarity score for it? So we do something called as we filter out the rank 1 and then get the similarity score and find the average. And similarly, for average top 3 elements, we just directly do top mean score of similarity score. Okay, this is for top 1 and top 3. And what we want to do is, since we have calculated the metric, we want to log that metric into MLflow as well. So what we do is MLflow.log metrics and give average top 1 similarity, what was the score, and then for top 3, average similarity score is average top 3 score, and total queries tested is equal to length of the test queries, which is nothing but 4. These are the length. Okay, this is the 4 test queries that we are passing. So this is how we log the metrics in MLflow. Now this is for metrics. Now we want to log the model, and we want to log the model, but we also have to understand, the MLflow should understand that what is the input it has to take, what is the output it has to generate from that model, and what are the parameters for that specific model. So what we do is, for inferring the signature, we just pass in the test query. Test queries is nothing but a list of sentences. And what is the output? This is the output for the specific model. Okay, so we want to infer the signature from these two inputs and kind of create a signature variable. Okay, so when we log the model, we want to pass this signature. Okay, so in the next step, what we do is, so we use something called as MLflow.sentenceTransformer.log model, and we pass the model here. And then we give the name of the specific logged model as semantic search model. And then we pass in the signature. Once the signature is passed, we pass a sample input, which is the test query, just two samples that we pass. Now this is model info. Now what we do is we just print all these metrics that we got and return the model information, which will be seen in here. Okay, so let me run this. We are calling the semantic search system here. Okay, let me run this and we'll see what will happen is it will try to download the model, it will try to create the embeddings, it will try to search for the 4 test queries, and it will try to calculate the top 1, top 3 similarity score for each. Okay, so if you see here, it is searching for this specific query. This is the top 3 similar items, and what is the corresponding similarity score. Okay, and what is the corresponding document. Similarly, for this specific query, what is the similarity score and which document got pulled up. So these are like top rank 1, rank 2 and rank 3. Similarly for rank 1, rank 2, rank 3 for this specific query and vice versa. Okay, at the bottom if you see, we have something called as average top 1 similarity score. What is the average score? 0.62. So if you calculate the average between 0.65, 0.61, 0.66, 0.5608, you will get an average of 0.6247. Okay, and when you calculate the average for all these 3 combined, okay, we will get 0.4361. Now this is with respect to the notebook what we have seen. Since we have logged everything into MLflow, let us see what is present there now. So let me refresh this. So this is my experiment, semantic search, and this is my run name, semantic search system. So here you will see we have our average top 3 similarity, which is 0.4360, so average top 1 similarity of 0.62. Total queries tested is 4, and this is the parameter that we pass to the model, which is max sequence length of 256, model name, corpus size is 8, and embedding dimension is 384. Now let us look at the model metrics. Okay, this is the graph for each of those metrics that we captured. Okay, and here we don't have anything, and if you see here in the artifacts, we have given log artifacts for the search results and corpus.csv. So we are able to capture those here. Okay, so you can see those queries and what was the document that got pulled up, what was the similarity score, and what was the rank. Okay, this looks very neat here. So this is how we can use MLflow for logging different metrics and how to capture various details of your embedding models as well. Okay, and see the performance. For example, in the next video what I'll do is I'll take in multiple embedding models and see which models performs well. Okay, what will happen is instead of using only one model and getting the similarity score based on that 0.62 is the average, right? If we have any other model, okay, which is performing better than this existing model, okay, we'll have a better similarity score for the same set of documents. Okay, so we'll try that out in the next video. So for this video, I think we are at the end of the video. So thank you for watching.